Hey, PCALC students, more FRQs to go over. This is year 2017, question number 5, and this style of question is a PVA, or position, velocity, acceleration. So hopefully at this time you are very familiar with this little moniker here, and as we go from position to acceleration, we take derivatives, and when we go from acceleration to position, we integrate. And so these are great little questions. You frequently get velocity because that'll require you to do both things. So one thing to notice on this question that made this one just had an extra little wrinkle was it's always this issue about position. And what's always frustrating about position is that it goes against your instincts as far as notation goes. And it's always super annoying when notation is something that is confusing, not the actual problem itself. And it would be so intuitive if acceleration was always a of t, velocity was v of t, and position was p of t, but it's not. So we're frequently, or you'll always see acceleration written as a of t. That's very common, and velocity is v of t. But when it comes to position, position is never It's never just P of t. I don't think I've ever seen it written that way. What they like to do is they use the letter S for a vertical moving problem, or they'll use x of t for a horizontal moving problem. So as long as it's vertical, we typically will see this, and if it's horizontal, we'll see this. If it's parametrically defined, you can even see y of t and x of t. That would be for a later course. But this particular question, they give us sideways movement. So of all the ways to get confused about position, it's going to be this one right here. And so once you get past that notation issue, the problem's not too bad. But I just wanted to review that little concept right here. So let's see what's going on in the question itself. It says two particles move along the x-axis for 0 less than or equal to t less than or equal to 8. The position of particle P at time t is given by x sub p of t is equal to the natural log of t squared minus 2t plus 10. So let's look at the notation they decide to use for this one. So for this one, they say, okay, here is the position function, and it is written as x sub p of t. Now the reason I'm pausing here is so you don't get confused about notation. So p doesn't stand for position, p is the particle p. So we have two particles moving along the x-axis for 8 seconds. So if you were to literally want to draw this question, you could say, okay, so I've got a point here that's moving along the x-axis, apparently back and forth, and that's point P. And I have another point Q that does the same thing. So P and Q just kind of go back and forth along the x-axis, and that's the question. So since it's sideways movement, it's x. So x tells us that it's sideways, P stands for the point P, and T is for time. So this is our position function, and again, since x is involved here, it means that we're going to have sideways movement. So since we're just along the x-axis, we don't have any depth. It's literally just this. This is what our position function, this is what our point is actually doing. So it's modeled by natural log of t squared minus 2t plus 10. And again, this is a non-calculator question, so this will all be we'll be able to work with it. The velocity of point Q, the other point is given by v sub q of t. So the other one, they say, well, that's v sub q, and they use capital here, of t. Well, that one's just the velocity of point Q. So the reason I'm stopping here is I want you guys to notice that the subscript is telling us whether it's point P or point Q. V is telling us velocity, x is telling us position. So there's our two functions, and they also tell us that particle Q is at x equals 5 at time 0, and we're probably going to need that. So that's just a little intro here, what's going on. Let's see what we can do here with the question. All right, part A says, for 0 less than or equal to t less than or equal to 8, find when particle P is moving to the left. Well, I want to pause on that one too. You guys know that if we have vertical movement, if the particle is going upward versus downwards, you know that this is increasing. And so if the position function is increasing, you know that your velocity is going to be positive. And if you're decreasing, your velocity is going to be negative. So this is a plus sign. So I know my velocity is greater than 0 when I'm increasing here. And here I know my velocity is less than 0, or it's negative here, it's positive here. It's increasing and decreasing. So if I said, when is the particle moving upward or increasing? When is it moving downward or decreasing? Vertically speaking, that's much more intuitive. Well, if we take this kind of question and talk about sideways movement, instead of up being positive and down being negative, left is going to be negative and right is going to be positive. So on the same question here, since we've got this type of movement now, you need to know moving to the right is when our velocity is greater than 0, and it's going to be positive. And if we move, so if we're going that way, and if we're moving to the left means our velocity is going to be less than 0 or negative. So the question says, when is the particle moving to the left? Well, we're going to have to find, just like here we would find critical numbers and test it for increasing, decreasing. We're going to find our critical numbers and test increasing, decreasing, but it's really just going to the right, going to the left. All the same stuff from before, it's just horizontal movement versus vertical. And that's the challenging part of the question. So when is particle P moving to the left? I need the velocity of P, and then I need to get my critical numbers. Well, what they give us is the position function for P, and so if we can take the derivative, which is the velocity, get our critical numbers and test it, it's a more normal looking question. So let's go ahead and just write the original function, which is x sub p of t, that's our position function, is equal to the natural log of t squared minus 2t plus 10. All right, so there's position. I need to take the derivative of that to get velocity and set that equal to 0 and undefined. So I'm going to take my derivative, I'm going to put x prime sub p of t, and I'm just going to write that that equals the velocity of p of t, and that equals, now we should take the derivative. So back over to here, I'm moving this way, I'm taking velocity, so I've got position. So since it's a natural logarithm, the argument goes to the denominator, and the derivative of the argument stays up top. So I've got 2t minus 2 all over t squared minus 2t plus 10. So I have to say, all right, when is that thing undefined? When does that thing equal 0? Okay. All right, so let's see, when is that undefined? Well, it's undefined when the bottom is equal to 0. Well, if you play around with this a little bit, you'll notice it looks like maybe it factors, but then it doesn't. It's got a plus 10 here, and you pretty quickly determine that this doesn't factor. And if you try to solve for t, you're going to find on your quadratic formula, if you try to solve that, you're going to find that your values there are always going to be positive. So we're not going to get any times where it's undefined anyway in our interval. So we're going to get no values here when it's undefined. Over here, when does this equal 0? Well, we just have to worry about the numerator. And so we say, oh, well, that's going to be 2t minus 1. So I get one critical number, and it's t equals 1. And then I would test it. I'd say, well, looks like I start at 0 and I end at 8, because that's the domain of t here. And I get one value. One critical number is t. Okay, so now if I pick a number between 0 and 1 and I put in the derivative, I want to see if it's positive or negative. So in the bottom here, no matter what you put in, or we'll just pick a half, let's just test it. If we put a half into the top, and I think what I'm going to do is I'll just write the factored form here. It'll make it slightly easier, not dramatically. And again, the bottom here does not factor. If we put in a half into the top, you can clearly see you get a negative number. And if we put a half into the bottom, we would get a quarter minus 1 and then plus 10. This plus 10 is making everything positive no matter what you put in here. So we get a negative over a positive, we get a negative. And normally we'd say decreasing, but instead of the word decreasing, I'm just going to put left. Okay. Now let's move this over to the side here. T equals 1, because this is the velocity, and this is telling me about position. Okay, and then pick any number between 1 and 8, 5. Okay, you put 5 into the top here, you're going to get a positive number, and 5 into the bottom, you're getting 25 minus 10 plus 10, it's still positive. So you get a positive over a positive, and so instead of increasing, we would just say it moves to the right. Okay, and so the question says find all the times, or when is the particle moving to the left? Well, the particle is moving to the left. I'm going to say particle P moves left for 0 less than or equal to t less than or equal to 1. And because actually at 1 it would be 0, it's not a negative number, and at 0, if you put that in there, you actually do get a negative number. So we get to include 0, we don't include t. So there it is when the particle moves to the left. And so if you can make the little adjustment from increasing, decreasing to left and right, that's it. That's all they're wanting you to notice here. Okay, part B. Part B says, same time interval, find all the times in which the two particles travel in the same direction. Well, we've got the direction done here for particle P, so let's see what we have for particle Q. Well, particle Q, they gave us the velocity already. We don't have to take a derivative. So let's just do our interval test on particle Q, and let's see what we get. So V of Q is equal to t squared minus 8t plus 15. So I need to figure out when is that undefined, and when does that equal 0. Okay, so just to pause here, remember, for particle P, they gave us position. That's why I had to take the derivative to get the velocity. Particle Q, they don't give us position, they give us velocity right away, so I'm already here. And so this is never undefined. And over here, this factors pretty nicely into, if we passed Algebra 1, we should be able to factor that. So 3 and 5, so it looks like we get minus 3 minus 5. And so it looks like our critical numbers then, t is equal to 3 and 5. So let's do that interval test. So looks like we're going from 0 to 8 again. But now I have 3 and I've got 5. And so I want to see what's going on here. Alright, so here's our factored form, and we're going to pick a number in the interval 0 to 3. Let's pick 1. If you put 1 in here, you get a negative times a negative, which is a positive, so it's moving to the right. Pick a number between 3 and 5, 4. 4 minus 3 is 1. 4 minus 5 is negative 1, so we get negative times a positive is a negative, so it looks like it's moving left there. And then a number between 5 and 8, how about 6? 6 minus 3, 6 minus 5, they're both positive, and so it's moving to the right. Okay, so let's compare this up here to this up here and see if we can get some commonality. So the question says, for this time interval, find all the times when the two particles are moving the same direction. So let's see what we have here. We're moving to the left when things start with point P, and we're moving to the right all the way till 3. So you guys can see they're not moving the same direction here for the first second. And for the second, but after point 1, this one's moving to the right, and this one's moving to the right. So this one moves to the right the entire time. It looks like this one moves to the right from, it would be from 1 to 3, but then it goes left, and it picks up again from 5 to 8. So it kind of looks like on this one, it looks like I think we're going to have two intervals where we both go the same direction. So I think jump to another color here just to show you what I'm meaning here. Overlapping these two graphs right here, I can kind of see if I were to bring this down here and I put point 1 right there, and if I were to, let's do this. Here's the points they have in common, 3 and 5. So I'll put a 3 and I'll put a 5 right there, and I'll put a 1 down here. So these are the values that we're contrasting. So let's see what's going on. From 0 to 1, they're going opposite directions. But after 1, this is going positive, and this is still positive. So it looks like this is a good section where they're going the same direction. They're both going to the right. Okay, and this point P goes to the right the entire time. Between 3 and 5, though, this one's going left, that one's going right, so that's no good. From 5 to 8, we're positive and going to the right, and this one was positive and going to the right. So it looks like we are good from this section and this section right here. Okay, now you could line those up closer, but that's basically what you want to do. You just want to just analyze them that way. And we could say P and Q are both moving And it looks like in both cases we're dealing with positive, so they're both moving right in the interval. Let's go from, looks like we're going from 1 to 3. So 1 less than or equal to t, 1 less than t less than 3. And our other interval was 5 less than t less than or equal to 8. Okay, and we only include the 8 because that's giving us the positive number in both cases. The other cases give us 0. So there's our test, and so they're there. But actually, we have all of our work shown. That's justification I'm looking for. So there it is, comparing those two graphs. Now, if it would be a little easier for you if you would actually put these two number lines or interval tests right on top of each other. You could see them pretty clearly, so hopefully that made sense there as I was analyzing. All right, now let's move on to part C. So what do we have here? Now it says, find the acceleration of particle Q at time equals t, or at t equals 2, time equals 2. And so I'm going to erase this over here to give us some room to work. So they're asking for acceleration, which if we have a velocity function, this should be pretty easy, again, because it's PVA. So let's see which one of the two functions they're asking for here. So find the acceleration of Q. Well, that's actually going to be an easier question because they gave us the velocity function and it's a quadratic. So we got t squared minus 8t plus 15. So acceleration, well, let's just find the derivative here. So the derivative of velocity is equal to acceleration. And that's a pretty friendly function there, 2t minus 8. All right, so we found that, and then they wanted it 2. So let's find this at 2. Looks like it's negative 4. Now, just for practice sake, since we're finding acceleration, they actually don't give us a time interval. And sometimes when you get particles moving along the axis, you don't get any units of time. So if they don't worry about inventing them. It's just negative 4, and we know it's acceleration. But just to review, the time unit would be squared, but it's just negative 4. Then the rest of the question says, is the speed of particle Q increasing, decreasing, or neither at t equals 2? Explain your reasoning. Well, this is a review of that concept that I'll put it up here. Remember, speed. Speed is increasing if speed is increasing if this is true. If acceleration and velocity have the same sign. Okay? And, brief review, speed is decreasing if acceleration and velocity have opposite signs. Okay? So all we have to do now, we have acceleration. Let's go back and check velocity. So going back to the velocity at 2, so what do we get there? 4 minus 16 plus 15. Is that right? So we have a negative 1, so it looks like it's going to be positive. So VQ of 2 is, we can put greater than 0, or we can actually put them out because we're comparing these two right here. All right, and so VQ of 2, we have 15, and 4 is 19, so we get a positive 3. All right, and so then for our conclusion, we could say speed of particle Q is decreasing at time equals 2, then a little neater, at t equals 2, because the acceleration of Q at 2 and the velocity of Q at 2 have opposite signs, or we can say have different signs. Okay, and that is part C. Okay, now it's part D. So D says, find the position of particle Q the first time it changes direction. Okay, so now, I'm not surprised they want position of Q because they gave us velocity, and now they're going to test our integration skills. So if we integrate, so just a little review here, remember, if you integrate from A to B, velocity, and I'll just put dx, okay, that means you're going to get position. But you're going to get the position at B minus the position doing the fundamental theorem at A. But just a little review concept here. So they said to do this, when is it first time it changes direction? So that brings us back to question B, and the first time it changed direction was actually at 3. So what I'm going to do is integrate from 0 to 3 the velocity function, which is, I'm going to write it here as v sub q of t dt. That's what I'm integrating, and that's going to give me the position, and I'm going to use x sub q. So that's going to give me x sub q at 3 minus x sub q at 0. So you want to make sure you totally understand that notation there. I'm integrating velocity from 0 to 3. Because it's sideways motion, my position function is an x. So the integral of velocity is position, but it's x, and it's from 0 to 3, so it's x sub q, because q is the point at 3, minus the x of 3 at 0, because that was the interval 0 to 3. So this right here is what they want to know. The question says, find the position of particle q the first time it changes direction, which is at 3. So we have to isolate this. So I'm going to take this and add it over, and I'm going to say, well, x, this should be q. X sub q at 0 plus the integral from 0 to 3 of my velocity function, which I'm going to put in here now, which was t squared minus 8t plus 15 dt. That's going to give me the position of q at 3. Okay, so again, this was just the fundamental theorem up there, isolating the 3. So x sub q of 0, it's been a while, but go back to the original question. It says the particle q is at position x equals 5 at time equals 0. So they never give you stuff you don't need, so there it was, 5. 5 plus the integral of this right here, very friendly integral. We get t cubed over 3 minus 8t squared over 2, so that's going to be minus 4t squared plus 15t, and we're going to evaluate that from 0 to 3. Okay, so this 5 I'm just going to drop down to here, and we'll add this to our final work here. So just this integral piece right here, I'm going to put a bracket right here to keep it separate. So we put in the 3 here, we get 3 cubed is 27 over 3, which is 9, minus 3 squared is 9, times 4 is 36, and then we get plus 45. Then you throw in a 0, and you just get minus 0 for all of that. So what do we get here? 54, is that right? 54 minus 36. Okay, and we still have this 5 down here. So let's see, this entire thing right here, 54 minus 36, I think we get 18 there. And so this whole thing became 18. I'm going to leave this 5 right here. So I get 5 plus 18, and my final answer is 23. Okay, and again, when you get these kind of questions, there's no units of time or distance, so it's just 23 is your answer. Okay, and so question A was worth 2 points, question B was 2 points, question C was 2 points, and this last one was 3. And so PVA question, and so whenever you get those, you got to anticipate you're going to have taking derivatives and also integrating. And so I liked C and D. That was pretty nice and straightforward. And but you had to get these values correct here with your change of direction. So the curveball in this question was getting used to horizontal movement versus vertical. And if you're okay making that adjustment, not a bad question. Okay, so there it is, 2017 AB exam, question number 5, PVA. Thanks for watching. Catch you next time.